That's good news. Our missing submarine is located. Of course, it's on the bottom, but now we can send DSRV. DSRV, Deep Submergence Rescue Vehicle. It works. Of course, they're already working, the DSRV crew. They're on alert ever since that submarine was overdue in filing a check report. They can be alerted after a known accident, or when contact with a submarine is lost for an extended period in an organized exercise, or when there is reason to suspect that a casualty has occurred. But this time, the sub didn't report, and DSRV is ready, just to be sure. Every system is groomed for maximum readiness. Pre-selected mission equipment is checked and loaded for transit. Briefings are held. All 15 of the DSRV crew are working hard. A successful rescue requires a lot of teamwork. They're part of the team. This fiberglass skin is for hydrodynamic streamlining only and is free flooding. Inside, 3 connecting pressure spheres, each 7.5 feet in diameter, hold the controls, diving crew, and rescuees. Most of the systems and units are in smaller containers in the free flooding areas fore and aft. These containers are pressure compensated. The response phase starts when the DSRV is ordered to move. Depending on the distance to the disabled submarine, the DSUB, DSRV goes directly from its own waters or is moved overland to a port with proper facilities nearer the distressed sub. But in this case, that sub is remote, and the DSRV must go to an airport for airlifting. The basic coordination is part of the rescue system and was worked out long ago. The Military Airlift Command of the U.S. Air Force provides the 3 C-141 aircraft for the airlift. As soon as a sub miss is suspected, the Air Force is alerted. They are important members of the team. Simultaneously, the nearest nuclear submarine modified to be a mother sub is shifted from previously assigned duties and directed to the remote port. The mother submarine has many special equipments and systems which were installed long before the emergency arose. At the same time, its crew received special training. They also are on the team. The DSRV and all its support equipment are en route to the remote port. These remote ports around the world are pre-selected. They have adequate piers, cranes, etc., with a nearby airport having appropriate runway widths, lengths, and loadings. These required facilities are checked out. Even the roads from the airport to the pier are mapped, considering width, overhead clearance, and corners that the land transport vehicle can negotiate. The DSRV is about 50 feet long, 8 feet in diameter, and weighs 35 tons. One C-141 carries the DSRV. 2 more C-141s carry the support band, skirt, and mother sub pylons, auxiliary equipment, and the DSRV crew. At the remote port, a United States representative makes arrangements to receive the rescue vehicle and its support equipment, and move them from the airfield to the port, and takes care of all customs and logistics problems with the help of local officials. Of course, the people first on the scene are still working too. They're vital members of the rescue effort. They're sending back information on subsurface topography and temperature profiles, wind and sea conditions, currents, existing weather, and the long-range forecast. Now, it all comes together. Part of the mother sub special equipment are TV cameras. which observe the DSRV when it's piggyback on the sub. Once loaded, the mother sub and DSRV head for the search area. On the surface, they proceed at speeds limited mainly by the sea state, or they may move at 15 knots submerged. When the DSRV arrives at the scene and the search force narrows the location of the distressed submarine to an area 6 miles in diameter or less, the rescue operation shifts to the localization phase. Sonar men on the mother sub are listening because the crew on the dis sub are also working. They too are active in their own rescue effort. They're helping the localization phase with the distress pingers, underwater telephone, submarine sonar, and just simple hull tapping. On board the mother sub, other rescue system operations continue. Before launch, responsibilities of the first crew are study the available data and develop an operating plan. The alternate crew aids and participates. After developing the plan, the operator and co-operator go through their checkout procedure, and the other crewman takes care of his pre-launch duties. The vehicle's effective search speed is 1 to 2 knots. The DSRV uses the planned navigation course, dive angle trim, speed, and active-passive location procedure. Refined information from the onboard sensors may change the original plan. Using its integrated navigation system and sonars, the DSRV navigates in relationship to the search target, fixed navigational points, or the mother sub. An onboard central processing computer integrates the data from sensors and controls, monitors all vital vehicle functions, and provides information to the operators. The vehicle's intercom links the 3 spheres. Speech and other data are recorded. The DSRV also has a UHF radio for communications while on the surface, and underwater telephone for communicating while submerged. It communicates with the mother sub at regular intervals, relaying additional data. All significant sonar contacts are reported immediately. Sonars are used to locate the dis sub by watching for returns from the submarine's sail or hull. Directional listening hydrophones may be used to listen for sounds from the bottomed submarine. When the sub is located, the mission moves into the rendezvous phase. The DSRV homes on the distressed submarine with assistance from the dis sub if communications have been established. Rescues can be accomplished with a passive, disabled submarine. However, the dis sub can provide information to help the rescue mission. If communications have not been established with the dis sub, the DSRV will determine the extent of damage. For visual observation at close range, the vehicle has 5 viewports and 6 television cameras, as well as external lights and film cameras. The DSRV fixes the dis sub's position. The vehicle is equipped with 2 releasable miniaturized homing transponders, HTs. The vehicle returns to the mother sub if time does not allow initial mating on the first trip. Propulsion and control are provided by a stern propeller within a movable control shroud and 4 ducted thrusters to control pitch and yaw. The DSRV has a sprint speed of 4.5 knots and a maximum sustained speed of 4.1 knots. In mating to the mother submarine, the various ballast systems are adjusted for a neutral attitude. The DSRV eases onto the pylons at near 0 velocity. Then it notifies the mother sub when the pylons and mating skirt have positive contact. The mother sub crew verifies that the DSRV is in position and actuates the pylon latches. For the first rescue trip, life support supplies must be replaced, batteries recharged, etc. Crew substitutions can also be made. The mission moves into the rescue phase, and the DSRV returns to the disabled submarine for mating. The final approach to the submarine is made with the shock mitigation ring lowered. The DSRV hull withstands an impact up to 85/100ths of a foot per second, but the shock mitigation assembly withstands impact up to 2 feet per second. The vehicle sets down on the hull of the DSUB. Then the manipulator clears the hatch. First, the messenger buoy cable is cut. Then the manipulator's water jet clears any debris from the hatch area. Mating begins with the DSRV aligned to the hatch and with the shock mitigation ring extended. When centered over the rescue seat, the shock mitigation ring is retracted and the dewatering pump in the skirt is started. As the water is pumped out, a pressure differential is created, pressing the DSRV against the sub, ensuring the seal. Now, compartment pressure becomes important. The pressure in the forward control sphere of the DSRV is maintained at a constant 1 atmosphere. However, the pressure in the mid and aft spheres is variable from 0.8 to 5 atmospheres to match the pressure in the DSUB. When the pressures are equal, the hatches separating rescuers and rescuees are opened. Next, if they are needed, the DSRV offloads supplies, such as oxygen flasks or carbon dioxide absorbent canisters. Water, equal in weight to the rescuees, is discharged from the DSRV's rescue ballast bags into the DSUB's bilges. Now, the rescuees are loaded on board. 24 rescuees are carried each trip. Normally, 6 trips evacuate a nuclear submarine. Separating is essentially the reverse of mating. Upon return to the mother sub, if the rescuees require decompression, the DSRV is mated athwartships to the forward hatch to offload rescuees into pressurized compartments, then moves to the aft hatch for replenishment. When the last rescuee is aboard the mother submarine, the mission begins the return phase, and all the support equipment is returned to rescue unit home port. This return is normally the reverse of the response phase. The DSRV can also work from an ASR-21 submarine rescue ship, which is equipped with decompression chambers and other deep diving systems. The catamaran ASR launches and recovers the DSRV through the center well. The DSRV may be supported by a ship of opportunity if a mother sub or ASR are not available. The DSRV has many safety features. In the event of entanglement, the manipulator can be jettisoned, as can the downhaul winch and the pan and tilt TV units. All ballast can be released to increase buoyancy. There is an independent emergency power system, an emergency breathing system for each sphere, and fire extinguishers in each sphere. That's the way this team makes a rescue mission work. Every phase successful. Alert. Response. Localization. Rendezvous. Rescue. And return. Maybe the sub will be recovered. We'll try. But #1 priority is recover the people. That's what DSRV does.